So, I get the pleasure of just introducing myself today. So I will tell you that I am not Marcin Sokowitz. I don't even say his name right. But Marcin, just to give you a little background, Marcin was supposed to be doing a talk here, but they've just had a brand new baby. And it was off schedule a little bit, as babies, don't follow schedule, right? And so he is staying with his family. We're really happy. We're supporting that. So I am stepping in to do a talk here. But shout out. We're recording this. Shout out to Marcin. He has helped put this event together. He is local. He's part of your local community. He works with Ryanair, and he's fabulous. So Marcin, thank you very much. I hope I do you justice here. All right. That being said, tell you who I am and what we're going to talk about. So my name is Eric Johnson. I'm a developer advocate for Serverless. I've been with AWS for 6 years in October, and I love what I do. So my team is actually part of the team. My team and a couple of our teams are one of the ones that put on this event, and we're just thrilled again to be here for the first time in Poland. And I love to talk about EDA. I'm a serverless guy, but the fun thing is almost all serverless is EDA. Well, not all EDA is serverless. All serverless is EDA. And there's some who may debate me on that, and they're wrong, and that's okay. But today we're going to be talking about how do you build next-gen applications using EDA. We're going to talk about some patterns and how do you apply those and things like that. So real quick, a little bit about who I am. Like I said, I'm principal DA for Serverless. I've been a developer advocate I've been a developer for about 30 years. I've been a solutions architect for 10 years. There are some who argue that I'm either one of those. I am a father of 5, so that's crazy. Now, you may be looking at me right now and going, that's not a 5, Eric. And I know that. Okay, so there's a couple of rules when I'm talking. Rules is probably a strong statement, but a couple of guidelines that'll help you. Now, did anybody see me talk yesterday? Okay, all right, so you're in to do this again. You guys are crazy. All right, but it will be a little different because I don't have a good enough memory to do the same. But when I talk, there are some rules, and they're basically this. This is any number I want it to be. Okay, I'm going to hold this up. I'll say 5, I'll say 20, I'll say 30. It just works, okay? And it's been that way all my life. So that's 5 kids. Now, I can get to 4 if I take my shoes off, but it gets really awkward for everybody, right? So this is any number I want it to be. These are quotes, not apostrophes, right? This looks better than me doing this, right? And finally, these are thumbs, right? I do this a lot. I give people thumbs up. If you know me at all, how you doing? I'm like, hey, and I do this because this will get you beat up. Okay, so these are thumbs, right? So just a couple of rules I'm talking that helps out. Now, I was born this way. I did not wake up this way for the first time today. If I did, I wouldn't be here with you, okay? I like you, but not that much. I'd be somewhere coping, right? So, but I do tell a lot of one-finger jokes, and I'm very, very comfortable with that. However, and I'm really serious about this, if that makes you uncomfortable, I'm also comfortable with that. So I'm good either way, and we'll have a good time. So, all right, so let's get started. That's what I look like, in case you can't tell. It doesn't get any better than that. That's how it is. So. All right, so let's get it's working. All right, so our agenda today is we're going to talk about a couple things EDA. First thing, we're going to talk about coupling. When we talk about event-driven architecture, we talk about distributed applications, the idea is we want to decouple. So we're going to talk about what is coupling and what does that look like. Integration patterns, what is an event? Event-driven architectures, and finally reducing event duplication with idempotency. And that one right there is a fun statement. Anybody know what idempotency is? Okay, a lot of you, okay, but do you really? I know that word's like, I start saying that word, I say idem, and I get that far, and I don't know if I'm supposed to end with idempotent, idempotence, idempotency, I don't know. And so what I end up saying is, today we're going to talk about idempotency. So you all get that. So yeah, idempotency, it's an interesting concept. So we'll kind of jump in. All right, so let's talk about coupling, right? When we think about coupling, is the measure of independent variability between connected systems, right? How much are you reliant on another system? If they go down, do you go down? How tightly are you coupled, right? Decoupling has a cost and design and runtime. It's not binary, right? There's multiple facets to this, and it's not one-dimensional. So there's a lot to think about when we think about coupling and what does it mean. Now, when we kind of put that, there's a lot more to this. This is really interesting. When we think about coupling, most of us think about it as like one function calling another, or one Lambda function calling another, if you live in the serverless world. But there's a lot of different coupling. These are some things I hadn't actually thought about when we were thinking about, all right, what should be on this list? And you think about, well, the technology itself, Java versus C++. A lot of times when we build an application, when we choose the language we're going to build it in, that's the language we're stuck with, right? Unless we want to redo it later. Now, that changes when we have things like Lambda functions where you can just, this one we're going to do it this language, this one we're going to do this language. But when we build monolithic apps, we're kind of stuck with that. So there's a coupling there. There's a dependency going on. Location, IP address, DNS, we're tied to those. Things like data type or interaction style. All kinds of different things can be coupling, right? And so we want to try to remove as much of these as we can. Now, will we remove all of it? Probably not. But here's an interesting statement. We've referred to Gregor Hope a couple times in this. He's a brilliant guy. And he has this statement. He says, the appropriate level of coupling depends on the level of control you have over the endpoints. Now, think about that statement, right? Because when we think about decoupling, or we think about being dependent on another API, we've all been there. How many of y'all are developers in the room? Okay, so most of the room, all right? Okay, I know a couple of you, and that's a lie. No, I'm just kidding. You're all developers, right? So it's really interesting when we talk about decoupling or when we talk about being dependent on something else, it never fails. Look, I manage this API, so it's going to be fine. Or I manage this service, so it's going to be fine. There won't be a problem. I can change it. But at some point when you're building an application, there's a point where they say, hey, we have this third-party location app or this third-party, whatever app that we want you to use. And you no longer have control. And so we write into the system, we write, in this linear factor, we say, okay, make a call to that API, and when it responds, do this thing and this thing. And when it doesn't respond, that's when we have a bad day. That's when you get the call in the middle of the night and we go, man, did we handle that properly? And so we're going to talk a little bit about that and the idea. Now, life is beautiful when you have control over everything, but life is not real when you have control over everything. The reality of life is you're going to use other services and you don't control those. All right. I don't know if I just have to point it at it. Here we go. Okay, it's coming up. It's not every time I push the button, so I don't have control over this. I'm dependent on it, so I'm coupled. All right, so integration patterns. So I want to talk about some of the integration patterns that we see in the wild and kind of respond to some of these. And the first one we see is, and we've all seen it, if you're a developer and you haven't seen this, you might want to rethink that developer label, right? Because this is a very standard thing that we do all the time, and that is the synchronous request response model. And it's very simple. I make a request, I get a response, everybody's happy. We love this, right? And it's a fair way to approach things, and there's some advantages to this, right? The first is it's low latency. Man, you make the request, you get it back. Unless your back end's doing a lot, it's usually pretty low latency. The second is it's simple. This is what I want you to do and give it back. The third one, and this is my favorite, is it fails fast, right? We never want to associate good with the word fail, but in reality, when we say fail fast, that means we get an answer. We know this isn't going to work, right? Because if you're a developer, like we all talked about, and I am, we can debate that, and we'll get into that in a little bit, but it never fails that everything works locally. In fact, I was just talking about someone about this. Everything works in development, right? It doesn't fail until you get to production. It never does, right? We've all been there. So when we build things like this, we want to fail fast. We want it to fail in testing. So that's where synchronous comes in really handy. However, there are some disadvantages to this. The first is when this fails, that fails, right? When your receiver fails, you're dead in the water, okay? And we all know that when a client sees a spinning wheel, they're only going to watch it for so long until they move to the next company, right? So that's one of the things. The other thing we have is what we call receiver throttling, right? And so while it may be up and running, it may not have the power to the synchronous. You may not be able to keep up with all the clients coming in. So you get into building, duplicates and all that kind of stuff, state management and all those kind of things that, because I work in serverless, I really don't have to deal with as much. So, but this is a model we see a lot. Now, one of the answers that we have to this that is a really good way is to look at the asynchronous model. And this particular example is the asynchronous point-to-point model. Now, When we think about synchronous versus asynchronous, I'm not going to define that in here. Hopefully you understand that. If you don't, I'm glad to have that conversation. But one of the things we talk about when we build event-driven architecture, when we build serverless, is get to asynchronous as fast as you can. Right? Now, it doesn't mean we shouldn't use synchronous, but synchronous should be used sparingly. Use it when it's absolutely necessary. Use asynchronous when it's not. Why? Well, I'll tell you why. So when we look at this pattern, so what we've done here is we've dropped a queue in the middle of our sender and a receiver. And the advantage to this is, number one, it's going to decrease that temporal coupling, right? It's going to increase, or I'm sorry, I said increase, decrease. The sender is no longer dependent on the receiver. The only thing it's depending on is the queue. Right, and the queue is built to be failure. You know, it's redundant. It's built to handle that. And the queue's job is just to simply acknowledge the request. So in this pattern, the sender says, "Hey, do this." The queue says, "Hey, I got your request," and then the sender gets to take care of that. Right, and so the other advantage here is it's resilient to receiver failure. If the receiver is not available, the client or the sender can still just keep dumping events into the queue. And when the receiver comes back up, then it's cleared out. And the third thing is the receiver controls the consumption rate. Okay? Now, we've all been there. So we get this new job, we're developers, we come out and go, okay, I'm a developer, I got a job, and you come in and say, okay, and the company says, all right, we have this really cool system, it's a legacy system. It handles 2 requests a day. Okay? But right now, we're getting 300 billion requests per second. We need you to make that work, right? And maybe that's a little exaggerated, but you know what I'm talking about. It's like, look, we're running an AS400, and I probably shot over that. Some of you know AS400. We're running an old mainframe, and we want you to handle thousands of requests per second. And you go, well, how am I going to do that? Well, here's your answer. With this, the client doesn't, or the sender doesn't control the consumption, the receiver does. The receiver grabs stuff off the queue as it can handle it, right? Now, granted, that's backing up too far. You may need to double up on your receivers, add more, but you have control over this without failing, right? So this is really helpful. Now, the other advantage of this is it adds the ability to have a dead letter queue. So your first queue is saying, all right, so and we're going to I'll show it to you in a minute, we're going to talk about SQS, but in SQS, it's built into it to say, hey, if your receiver's having problems, there's something like that, then let's go ahead and retry. So you have this retry built in. And then if that continues to fail, then I want you to drop that data into what we call a DLQ. I always want to say DQL. DLQ, a dead letter queue, meaning, hey, this isn't working, but I don't want to lose the data. Because the last thing we want to do is have to call a customer and go, hey, yeah, you remember that credit card number you sent us? Could you send that again? Yeah, we'll get it right this time. You know, that's a credibility problem, right? And so we've got the data still. Now, hopefully you're not collecting credit card numbers. That's a whole different kind of thing, you know, compliancy thing there. But for my example, you understand. So in this, you're able to drop data into a DLQ, and then you can automate against that and handle that. Right? The other advantage is only one receiver can process messages. And I'll get into this a little more when we're talking about idempotency, but the way SQS is set up is you only one receiver processes this, or should be. Right? And in a happy path, that's the way it's working. There's a couple of disadvantages or challenges that you want to work on or work with. One is response correlation. And this is that, and if you were in it, Josh was talking about it earlier and talking about how do you get back. With an asynchronous pattern, your client's no longer getting that response immediately. Hey, I did the work and here's the answer. Instead, you've got to have a way. You need to either have your client pull for the data, or you need to either have you need to communicate with that client somehow. So, am I too loud? I'm like, okay, I want to make sure. I have a very loud voice, and they put a mic on me, so I just want to make sure I'm not blowing y'all away. All right, so, and then fairness of multi-tenant systems, how do you balance that out? Getting that working. So, the other one, backlog recovery time. I don't really see this personally as a disadvantage. We put it on here, but in this, what this means is, hey, you got a backlog. Your receivers went down, you got a backlog, how do you take care of it? So that can take some time to do that. But to me, that's a lot better than going, hey, there's no backlog because we lost all the data because the receivers went down. Right? So if I got to choose one, that's the one I choose. All right. So the service we use on this, Amazon SQS, there's a couple of them. Amazon SQS is real standard for us. It's fully managed messaging queue, scales almost infinitely. I love that. It's actually in the document. Scales almost infinitely. You got stuff, we can handle it. just pump data as we can handle it. So it's a very, very powerful system. It's one of the first serverless systems that came out. Another one is Amazon MQ. If you want to run like ActiveMQ or RabbitMQ, you can do this kind of thing. All right, so there's another type of way to handle this to get out of synchronous and move to asynchronous. And this is called the asynchronous broadcast model. And you've probably seen this a little bit today. So we're going to do a topic. And how this works is the sender, again, sends, and this time we're going to send to a topic, right? And the topic acknowledges, yes, I got it. And then that topic then pushes a broadcast to multiple, anybody who's subscribed to that topic, right? And so then you can say, all your receivers get it. There's some filtering you can do to say, hey, don't process this one for this sender, that kind of thing, when you subscribe to that. But basically, it takes one message and it broadcasts to many. So it's kind of a one-to-many idea. It's very helpful when you're pushing that out. Now, there's obviously some advantages. It decreases temporal coupling. It's resilient to receiver failure. Again, the receiver fails. The topic will handle the retry, right? Subscriber controls notification, so you can say, hey, I want this or I don't want this, and I can filter on that. And finally, each subscriber is notified when that's sent in. Now, the other cool thing is it can handle different types of things. So this one, I loved this when I found this out. I can send messages to your phone through this. That's how we're doing it out there at Serverless Presso. I can send stuff to webhooks. I can send stuff to lots of different things. So I can have, if I've got a message that says, hey, alert, the factory's down, it can send emails to some people, it can send SMS messages to others, it can call webhooks, all from that one message. So it's a way to broadcast and cover, for many of them. So this is a really powerful way to handle that. And the service we use for this is Amazon SNS. It's fully managed pub sub, and again, it's unlimited power. It's crazy. All right, so the next pattern that we see in the wild is called the asynchronous point-to-point. Now, we're asynchronous, so that's good, but it's a point-to-point, and we're sending out data to channels, right? So we're sending out channels. We're saying, okay, this is, here's the service. Now, the way this works is the client kind of needs to know what's going on, right? So let's talk about the disadvantages. First of all, you have increased location coupling because the client needs to know where am I sending. If it's a purple, I need to send a purple. If it's an orange, it's basing these events. It's sending it. Now, and the sender maintains the routing logic. So if you think about this is really simple. You look at this, go, it's no big deal, Eric. I know that if it's a purple, I need to send a purple, and if it's orange, I need to send an orange, and that's fine. But what happens when you start building on? And I want to pause here for a minute and talk about how we approach building. A lot of times we approach building, we do MVPs, and we should build MVPs. That's the way to do it. But we tend to approach building as kind of happy path without the mindset of scalability and complexity. Right, and I encourage you later, David Boyne's going to talk about complexity in EDA. Hopefully you're building to have clients. Hopefully you're building to scale. And if you're just building, we don't really want business. We just want to see if we can make it work. I'm like, okay, well then, go as hard as you want. But if you're building for it to scale, which you should be, then you want to be thinking about that all the time. And you want to pick patterns that are easily changeable. And to have to add code or logic to your clients, to call your client and go, yeah, we've added another channel. We need you to have a pink channel. Yeah, add it to your code, and we need it done by yesterday. Okay. That doesn't work, right? So instead, and like we said, the disadvantage of this is it gets really complex. As you start adding more channels, that sender maintaining the routing can get really complex, right? And it just increases over and over. So instead, what we encourage you to do is to look at the bus, right? So it's asynchronous messaging router model using a bus. How many of you use buses now or EventBridge? I'll just spoiler, okay? How many? All right. Let me ask this: how many of y'all are using AWS at the moment? Okay, so most of the room. If you're raising your hand now, you're using an EventBridge bus. You just don't know it, okay? Because everybody has a default one, right? That's just the way it works. A lot of things is traveling around in the system. So how this works is, the advantage is no longer is the logic at the sender. It's not even at the receiver. It's at the bus, right? So, or at the rules, okay? So it's these rules that evaluate the events coming through, and if this passes, then it invokes a target. Let me explain that a little better here. So first of all, we'll talk about EventBridge, right? EventBridge is the service we use. It's a flexible, simple, flexible, fully managed pay-as-you-go event bus service. It makes it really easy and has partner sources, all kinds of things. So here's how it works. So you have these sources. It can be partner sources, AWS sources, your custom applications, microservices, all kinds of things, right? They produce events. And when we get further into this, you're going to see more and more about when we talk about events. But they produce events. They push them to the default bus or a partner bus or all kinds of things, but the bottom line is they're putting it on some kind of bus. Then, and this is where the magic happens, then you write these rules. And you say, I'm going to write this rule, and if it matches this rule, then invoke this target, right? So, and it can handle a bunch of different targets. So you say, okay, when it matches, then invoke a Lambda function or ECS. And I don't know if any of you are doing this, but this if you're following this would actually allow you to invoke an ECS instance or task on Fargate as an ephemeral compute, much like a Lambda, right? So you could actually target an ECS, it comes up on Fargate, it does the job, and then it goes away, scales back to 0. Really interesting idea. If you think about that, look, I need something that runs longer than 15 minutes, that's the way to go. You can do that with step functions too. All right, so what do the rules look like? So so let's say we have this event, right? This event from a video system that we built last year, right? And we write this rule, okay? And where it matters, we say, okay, we want the source has to be in this array of, and we've only got one in the array of com.flicks. So yep, we got a match there. And the region has to be either AU or NZ, and this is a AU, so it's a match. Therefore, it'll invoke the target. It's that simple, right? And you can do some little more complex than that, but the idea is, and you can trigger with a bus, you can trigger more than one target. So this is a great way. Again, today is all about event-driven. This is how you drive targets and drive invocations from an event bus, and this is a strong way to go. So you have over 30 services, so obviously as them all, but there's many services you can be targeted on that. All right, so we kind of talked about these couple patterns we see out there, and maybe how can we handle that. The basic idea is we move from sync to async, and there's some different patterns for that. Excuse me. But what is an event? So let's talk about that. Now we're talking about event-driven architecture. Josh stole my thunder. If you were in Josh's talk, we're not best buddies anymore. But he stole my thunder. But basically, I'm going to define event-driven architecture to you. If you weren't in there. If you were, then you get to hear it again. But it basically is this. This is very technical, so I'll probably have to do it twice. But stay with me. All right. Event-driven architecture is this: something happens, and we react. Too technical? You want me to do it again? Something happens and we react. Yeah, I'm oversimplifying that. I get that. But that's the idea, right? And so events happen. So we need to understand what an event is and how do we manage that event and how do we plan for these events. A lot of times we just go, it's an event, just run it, But you want to plan for this. You want to have a plan. I've said that 3 times now, so there you go. All right, so property is an event, right? So events they're JSON objects, right? So they carry a lot of data. But you want to make sure that events are signals. I just talked about this. Something happens, we react. Events are signals that a system state has changed. This happened. What do you want to do, right? So it's about events that occur in the past. It's not, hey, this is going to happen. Well, this is almost about ready to happen. It's this happened, right? They're immutable. It means they're not changing. You can't change the history of what had happened. And you decrease coupling by restricting information to key data, right? So these are some ways we do that. So we look at events and we go, let's just put everything in it, or we should just put a little bit in it with a pointer, those kinds of things. These are some things you need to think about. So we talk about this in 2 things. We have what we call sparse events, and we have full state events. Why would you use one over the other, right? So some considerations with sparse events. Right, we have this video, we really did build this video service at reInvent last year to show that you can do video with serverless, and it works great, all right? And so, but when you send this event, when you say, okay, look, here the data is the channel ID and the create time, and your publisher service, you have multiple services that are consuming this event, and your publisher service, hang on, what's the name of the channel? And your video manager services, what are the channel tags? And your video streaming services, what region are they in? All right. So they want data that's not available in this. So you have a couple of choices. You could say, okay, how about I cram all that data into the event? Or I can put a pointer where they can do a lookup. One is obviously less latent, but the other can be hard to maintain. All right? So when you're thinking about this, when you move into full state events, there's some considerations there as well, right? So we could add this data. Here's the description, here's the tags, the city, and those kinds of things. But the thing about it is events should be backwards compatible. So as you add and remove, or as you add stuff, you kind of have to keep other stuff. A great example of this is we had a system that was working, when I worked with the customer a while back, and they had order ID. And order ID was camel case, lower order, I, and then lower D, okay? So then they put that in there. And then one of the systems down the way said, no, order ID is snake case for us, order dash ID. So they said, okay, we'll add that as well. So now, every time your producer generated the event, it needed to add both of those, or you had to have a hop that said, okay, copy this to this, right? So now, and what happens is your event gets bloated. Now that's a really simple example, but you can see where this would get bigger and bigger as complexity is added, right? So remember, we want to always be thinking about what does complexity look like. So, and this could really come down to a cost to calculate values. Am I adding an extra hop just to duplicate order ID into a snake case property because I can't remove it or it'll break these services and I have to have this version or it'll break this service, right? And sometimes you just push back and go, change that to camel case, and that'll make us all happy, right? So, things you need to think about when you're doing that. All right, so that's when we're talking about how do we do events. And David Boyne, again, I refer to him again, he talks a lot about planning for events. There's also, you want to look at things called event storming and event planning when you're thinking about how those are going to work. All right. So let's get into actual event-driven architecture, talk about some of the approaches to this. First thing I want to talk about is choreographing events between domains. When we think about domains often, not always, often come down to teams as well, right? We think, well, we handle the user interface. We handle reporting. We handle social whatever. There's different domains. We handle delivery, those kinds of things. So back to our video example, we look at if we're doing this the old way, the non-event driven way. Let's say we have a new channel created and all these services need to know about it. The channel service, the video streaming, the manager, and the publisher. So what we would do is we'd have this new channel, our application, that part of the application would take and say, oh, okay, there's a new channel. Okay, I gotta let the video streaming know, hey, we have a new channel. I gotta let video manager know, hey, we have a new channel. And I gotta let publishers know, hey, we have a new channel. Okay, so another service comes in, I got to add that to the code. So I always have to go back to the client and say, hey, I need you to add this, and there's a lot of dependency there going on. But when we move this into an event-driven model, that's kind of what we talked about, this is a good visual of it. So what happens now is I say, hey, I got a new channel. Okay, I'm going to drop it, and this is in the broadcast model. I'm going to drop that into a topic. If you want to know about it, then subscribe. If you don't want to know about it, don't subscribe. My job is to drop it in the topic, and now I can add more and more services as I need. You can look at it at the router model, and you could say, hey, I got a new channel. All right, I'm going to drop an event into the event bus, and then each one of you writes a rule. If you want to know, then let me know, right? And so that's how it works. So this idea of choreographing events means how do we pass events back and forth between domains, right? Often that's EventBridge, SNS, SQS, different ways of passing those around. My go-to is EventBridge, just simply because I tend to think in that rule pattern. But if I have to broadcast, I'm going to go SNS. And then there's obviously a difference between that and queuing. If I need to queue stuff, I use SQS. So that's kind of the order that I think about things. The second part of this is we orchestrate the process within domains. And I added this later. So this blue was kind of added later, and produce one or more events. In event-driven, it's this idea of I did my job, produce an event. Oh, okay, that triggered, I did my job, produce another event. So you think about that. So let's say back in our service, we have two more services, right? And we're gonna add a video processing service, right? And this is a real service that we built. We built this for reInvent last year, and how it worked is you would record a video, and then we would process it. We'd use Gen AI to do the transcript, find out if there were dirty words in it, remove those, block it. We would send it. We actually used Adobe to do some cool Gen AI image creation, those kinds of things. And so we needed to orchestrate all of this. And one of the reasons, and I won't show you all of it, but I'll show you an example of this, is we had to evaluate the video and say, how long is this video? Of course, it was in the metadata. And we had a benchmark. We said if it's over 20 minutes, then it makes more sense to process it in ECS on Fargate than it did a Lambda function, right? Because the Lambda function at the 15-minute timeout may have caught up, and we may need to do more. So what we did is when the video was dropped into a bucket, that bucket kicked down an event and said, hey, I got a new video. That event, through EventBridge, then kicked off step functions, or step functions evaluated, said, okay, that's longer than 20 minutes, I'm gonna have ECS run that. Okay, it's shorter than 20 minutes, I'm gonna have Lambda functions run that. And they would just cruise it, and it could do multiple at a time. You run different step functions, you bring them up, and it was very fast and very efficient. Then we were done, we would write the data out to DynamoDB with all the information, do some of that, and then the last thing we would do is kick out an event. Okay, you start to see a pattern here, right? I do something in an event. And this allows this video producer service to not care or know about any other services. But we're able to add it because it can consume and create events. Right, so we look at this one, so the validation, so this is the step function to do the plugins, right? And so one of the things we need to do is things need to happen in a very specific order. So we needed to orchestrate this. So again, back to step functions. Anybody uses step functions now? All right, a couple of you, okay? The rest of you, you're getting a B right now. Okay, no, I'm just giving you a hard time. But you need to check out step functions if you get a chance. It's super powerful, and it gives you a lot of options, right? And it directly integrates with service, right? All right, so we have pre-validate plugins, post-validate plugins. We could run all these as needed. Here's what it looked like in the step function. We come in, we fetch the pre-validation hook. We did this for each one. I won't bore you with exactly what it's doing, but the main idea is it would run the process and then kick out an event, right? That we've done this, now you can move on to the next one, right? And that's just for the first part. Then it would run to the second, right? And again, we're doing this all through step functions. Super powerful, lets you do a lot of, just a lot of cool things. All right, so that's choreography and orchestration. And the basic idea I really encourage you is, orchestrate business process in the domains, and then choreograph events between domains as you're moving those around. Right? This is a very strong pattern for EDA. So let me show you an example in this serverless video that we built. This isn't going to be a video, but kind of get an idea. This is the actual, and I'm sorry that these aren't bright, but this is the actual event or serverless video architecture that we use. And you can see, all right, here's our different services. Here's our domains, the video manager, the video streaming, the channel service, all kicking out events into EventBridge rules, and then different things going on to take care of that, and then kicking events back in. So nowhere in here are we calling an API saying, hey, I did this, call another one, hey, I did this, hey, I did this. We're simply passing events around and tracking that through the system. Okay, so that's event-driven architecture right there. All right, so event-driven architecture, distributed applications, right? That's really when you use event-driven architecture, you're building distributed applications. The next part of distributed applications, and one of the challenging parts is we're going to come to, is this idempotency, right? So idempotency is always a battle, and when we think about that, we talk about duplicates in the system, right? So to give you kind of an example of what I'm talking about, I'm going to tell you a story here. Several years ago, just before pandemic, I was traveling to Turkey, and I was going to speak at Serverless Days in Turkey. I'd never been to Turkey before. I was very excited. And I got to Turkey, and it was a brand new airport called IST, the IST airport. You may or may not have been there. And I get there, and I'm standing in customs. There's all these customs booths. There's like 20 of them, and we're all standing in line, 20, 30 people. And I finally get up to the gate, or the teller, and I hand her my passport. And she takes the passport, she scans it, and then she does this. Now, I travel a lot, this is a red flag. She kind of looks at me, and then she does some typing, and she makes a phone call. She looks at me some more. She doesn't give me my passport back, and so there was a big glass here. So I leaned around the glass. I said, "Is everything okay?" And she said, "Get behind the glass." I said, "Okay." So I stood behind the glass. So I stood out there for about 20 minutes, and I finally told her, I said, "Look, I'll just get back on the plane. I don't got to come." So she says, "Just a moment." So she makes some more calls. At this point, 2 fully armed, fully body armored guards come out with big, I'm not talking a pistol or a stunner, I'm talking full rifles, body armor. They come out and they stand on either side of me. And they close the line behind me. And I'm thinking, this doesn't seem normal. This seems out of place, right? So they say, "Mr. Johnson, will you come with us?" And every part of me is like, no, I would rather not. But they said, yes, I was coming with them. So we went, and they took me to a guest room, which was a small room with no windows. And they posted up outside of it, and they handed my passport and my IDs and everything else they had to a guy in there, and he had a gun, and he sat down. And he wouldn't tell me what was going on. For an hour, we sat there, nobody would tell me. Finally, I said, "Just tell me what's happening." He said, "Well, Mr. Johnson, it seems there's something in the system, there's your name's in the system, Eric Daniel Johnson, with your ID and stuff, and it's flagging as a criminal." I was like, well, it's been a long, I don't know what to tell you. I'm not even going to make a joke there. I don't know what to tell you. That's not me, right? And he said, well, and he explained some things. So I said, well, let me ask you a question. I said, do you have prints on this guy? He said, of course we have prints on this guy. And I said, if you got more than 2, I'm not your guy. And it was just dead silence. He makes a phone call, words I don't understand, and he hangs up. He says, "Mr. Johnson, you can go. There seems to be a duplicate in the system." They had idempotency problems. They were not idempotent. Idempotency, or being idempotent, I used to think that idempotent was the bad word. It's actually the good word. Idempotency is important, especially when you're building distributed systems, because you deal with eventual consistency, you deal with a lot of different things. So let's look at what does this mean, okay? So idempotency, I'm going to give you several definitions. The first is the mathematical one. And the idea here is operations that can be applied multiple times without changing the results, right? So you get the same result every time. Here's a different one, and this is again Gregor Hope and Bobby Wolf. They said a message that has the same effect whether it is received once or multiple times, right? But this is just English instead of math. But I'll give you the real one, right? But these are real, but let me give you the one that hits home. It's this. Was my credit card charged twice from my mom? Right? We get this call. I mean, I'm sure if y'all have parents that's like, is something's wrong? Am I getting hacked? Am my credit card charged twice? Things like that. Idempotency is a big deal, right? And so we need to be working with that. So I'm going to walk you through there's many things you can do, but more, what can you do in the code before you ever get it into the database, right? All right, so my clicker, there we go. All right, so where can duplicates occur? So let's talk about some different places. So the first place that can occur is in transmission, right? So let's go back to this synchronous approach. So we have a sender, they're going to send a message, and the receiver acknowledges, but it breaks down the acknowledgement, right? And so what happens is this is where the duplicate message happened, because if you've written a good client, your client says, oh, okay, I've timed out, I didn't get a response, so I'm going to call the action again. But we don't know if the first call never made it to the receiver, or they didn't process it right, or it failed there. You don't know where it is. So this is where duplicates can and probably do happen, right? So how do we get around this? All right, so we'll come to that in just a minute. Let's talk about some other places. This is in receiver issues. Now, this is an SQSQ. This is how it works, right? So I'm going to talk you through this. I said I'd kind of walk through this. It's really cool how we do SQS. When you send a message into SQS, it actually is going to create duplicates immediately, and we store it in different places to build durable systems, right? Then when your receiver calls for that, either it's in the polar through a lambda or you're doing it through your code, it doesn't remove it from the queue, it hides it. Okay, so it hides those messages for a certain amount of time. If it doesn't get fixed, then they come back in. But that keeps other receivers from grabbing it. This is why you can have 30 receivers processing a queue, right? But if the receiver breaks down during that process, then we've got a problem, right? Then the second one may grab it after it times out, and now you have duplicates in the system, right? Because we don't know if that receiver failed, if it got it in there, you don't know, right? Another one is service issues. Now, Werner Vogel says everything breaks all the time. He's a CTO of Amazon. Everything breaks all the time. Mine is a lesser known quote, but it's just as true. Everything I build seems to break. Right? So, it's like, yeah, you don't want me as your developer. I'm an architect. But yeah, it's this idea of things break. So while we try to plan for not breaking, we need to plan for breaking, right? We build to not break, but we plan for breaking, right? And so in services, if we do, again, we're back to the same thing, and it doubles up, and then the receiver fails, but now the service itself fails. So we don't know, did the receiver process it or not? Now we have service 2. So again, transmission issues, receiver issues, service issues. These are all places where these can happen. And then obviously code. We want to do code to kind of deal with that, right? So let's talk about that. One of the ways that we can handle this is through what we call idempotency tokens, right? And an idempotency token uniquely identifies messages, right? And a well-behaved token is going to be generated by the client, not the server. If you're sending it to the server, you see the problem there. I may not get it back, and yeah, that's a problem. So the client's doing it. They're resent by the client when we retry, so we can identify that. They're unique per message, because they're an identification, so you want them unique. And finally, they use a dedicated field. And we'll talk about why in just a moment. But here's how they look. Is anybody using AWS Lambda right now? Oh, okay, very few of you. All right. Okay. Oh, that surprises me. Okay. So AWS Lambda, there's a software called Power Tools, or basically an extension you get called Power Tools. Very powerful. We built it. It's Python, Java, .NET, all kinds of different versions. This is how they handle idempotency in the code using tokens, right? So what happens is, in here, your client is going to call your service. It's going to send an event that's going to invoke it. Your Lambda function is invoked. The first thing it does is it looks up and says, is this idempotency token existing? If it is, does it have a response? So it'll say, oh, okay, no, it's not it doesn't exist, so I'm going to go ahead and write it to the database. In this, we use DynamoDB for persistence. We just call it persistence layer. Right? It's going to write it to the persistence layer. Then it's going to run your code. And it's going to store the output of your code back to that database. So it does 2 quick reads, right? And then it returns that data to your client. And everything works, okay? Right? So, but here's what happens when it doesn't work. Or here's why we do it. What if that return to the client fails? Well, then your client says, okay, I timed out. I'm going to go ahead and call again. And so the Lambda function then reads from the database and says, oh, this exists. And we're still under the TTL, I'm going to grab the response and return it, but I'm not going to run the code in the function. So I'm making the same call, getting the same response, but I'm not creating duplicates. Does that make sense? It's very important to do that. So you can build this on your own if you want, but I would look at Power Tools. It's built right in. They do it. It's very cool. It helps a lot. But that's an example of approaching that. Now, we also look at building idempotency into our services, okay? So, for example, if you look at SQS FIFO, which is first in, first out queues, the way this works, so we showed an example using AWS CLI. We would call it, we'd create a token, and we would actually call SQS, send message, and we would pass it actual token, right? And it's called the message deduplication ID. And you pass the token, and you can see we get the response back. So let's do the same call again, and you get the same response back. It knows, nope, you've already made this request. So it is, I don't know if the battery's dead. All right, I've tried it. We're just going to go back. There it goes. It is idempotent, okay? So that works. This service works. All right, so the next one, step functions. So step functions, we're going to do the same thing. We're going to actually generate a token ID, and this time we just use name. That's the idempotent key for step functions. We use name. And you can use a lot of different services use different things. All right, so you do the execution, we get it back, and you can see it's the same. This is the ARN that we're looking at the very end of the ARN in the yellow. And you run it again, and you get the same thing back. So this is idempotent. So both those services work that way. So let's look at Event Bridge. So Event Bridge, we're going to take and we're going to say, we're going to send data. We have entries. We get back an event ID. There's no place to do a dedupe code here. And then we send it again. And notice these numbers do not match. Okay? This is not idempotent. Now, it's not like we forgot. It's like we got Event Bridge all built and went, oh man, we forgot idempotent. Sorry. There's a reason it's this way. It's because you may send the same thing multiple times. It's an event bus, right? Events may look alike. You may have a bunch come in at the same time, right? So we know that, but you go, well, okay, Eric, well, what do we do, right? Well, this is where an idempotency token, you need to use it, but there's some work on the back end. Right, so what you would do is you would actually generate an idempotency token, and you can save it. And I recommend like a metadata. I had a conversation with somebody yesterday. It's like, well, why does it have to be in there? Well, it doesn't have to be, but it helps to kind of isolate it and things like that. But basically, you want a unique name that you can identify later. And we'll call it, in this I have idempotency key. All right, so I'm going to add that in the metadata. And then what happens is when I send that through, then my back-end service, whatever event is getting triggered or service, will need to check on that. Say, hey, has this key been done? So it's a little extra hop for you when using Event Bridge. But again, there's a reason for that. So that becomes idempotent, excuse me. All right. So the last thing we're going to talk about in when you're using idempotency tokens, again, this unique name, right? So I've seen this. This isn't I'll bet somebody does this. We see this all the time. Right, so I'm going to use this message ID, right? And remember I talked about sometimes it's hard to correlate. You need to send back a correlation ID. So my sender is going to send something to my receiver, and it's a message ID 123. The receiver is going to do the work. It's going to say, okay, I'm done. I'm going to respond to you, and I'm going to give you a correlation ID. And then what you do is you take your message ID, my correlation ID. If they equal each other, that's the job. That's what we're working on. And it works great. But what happens when again we enter that third, that third party that someone, someone says, hey, we want you to add this service in the call. So what happens, we send it, and we have this intermediary service. We say our message ID 123, but they also use message ID, but their message ID is 456. So now the receiver gets it, and message ID 456. They send it back to the correlation. And they say, oh, that doesn't match. And so then it doesn't work. So the point of that is you want to make sure that you're using a correlation ID that you can identify, that is unique and that you can make sense. All right. So with that, I'm going to give you a couple of resources really quick just to kind of learn a lot more about this. I just dumped a lot on you about EDA, and I hope that makes sense, and I hope that helps. There's a lot to build here. There's a lot of power in EDA, but you want to be careful as you plan, as you build. And hopefully this gives you some ideas. You see this several times. Serverless Land is a site that our team maintains. Julian and I are still maintaining it, and it's got a lot of data in it. A ton of stuff, learning, videos, blogs, workshops, you name it, and patterns, tons and tons of patterns. In the keynote this morning, David referred to those as patterns. You can look at it, how they work. SAM, CDK, Terraform, CloudFormation, SST, and there's a lot of different examples. So there you go. And finally, that's it. My name is Eric Johnson.